Welcome. Tonight, we're going somewhere very few humans have ever been. Deeper than mountains are tall. Deeper than light can reach.
Into a world so alien, so vast, and so silent that it makes the surface of the moon feel familiar by comparison.
The deep ocean. It covers more than half of our planet's surface.
It holds 97% of all the water on Earth. And yet we have explored less of it than we have explored the far side of Mars. Right now, as you listen to these words, creatures are moving through absolute darkness miles beneath the waves.
Creatures that glow. Creatures that have no eyes because eyes are useless where there is no light.
Creatures so strange that when scientists first pulled them to the surface, they weren't sure they were looking at animals at all.
The deep ocean is not empty. It is full.
Full of life, full of mystery, full of things we do not yet have names for.
Tonight, we'll go there together. Slowly. Quietly. Fact by fact, deeper and deeper, until the light is gone and only the soft blue glow of bioluminescence remains. Get comfortable.
Close your eyes if you'd like.
And let the ocean take you down.
The ocean is divided into 5 layers, each one darker and colder than the last. The sunlight zone sits at the top, stretching from the surface down to about 200 meters.
This is the world we know. Colorful coral reefs. Sea turtles. Dolphins riding the bow waves of ships.
Sunlight filtering through green water in long golden shafts.
Below that begins the twilight zone. Then the midnight zone. Then the abyssal zone.
And finally, at the very bottom of the deepest trenches, the Hadal zone, named after Hades, the ancient Greek god of the underworld.
Each layer is a world unto itself. Each one stranger and more silent than the one above. Tonight, we are going all the way down.
The deepest point in the ocean is called Challenger Deep, and it sits at the bottom of the Mariana Trench in the Pacific Ocean.
It is 11,034 meters deep.
Nearly 7 miles. If you placed Mount Everest at the bottom of Challenger Deep, its peak would still be more than a mile underwater.
The pressure at the bottom is over 1,000 times greater than the pressure at sea level.
A human body, unprotected, would be crushed instantly. The water itself behaves differently at those depths, compressed, dense, moving in slow cold currents that have not touched the surface in centuries.
And yet, life exists there.
Even there, at the very bottom of the world, something lives.
We have better maps of the surface of Mars than we do of the ocean floor.
Only about 20% of the seafloor has been mapped in high resolution.
The rest remains a blur, known only in rough outline, like a painting seen through frosted glass. The reason is simple.
Radio waves, which we use to map land from satellites, cannot penetrate water. To map the seafloor, you have to go there, sending sound pulses down from ships and listening for the echo.
It is slow work. Painstaking work.
The ocean is simply too large and too deep to map quickly.
Somewhere in the unmapped 80%, there are almost certainly mountains taller than any we have found. Valleys deeper than any we know. Geological features for which we do not yet have names. The ocean keeps its secrets well.
The ocean produces more than half of the oxygen in Earth's atmosphere.
Not forests. Not trees. The ocean.
Most of this oxygen comes from phytoplankton, microscopic organisms so small that a single drop of seawater can contain millions of them.
They drift near the surface, photosynthesizing in the sunlight, exhaling oxygen as a byproduct. Every second breath you take came from the sea.
When you breathe in tonight, as you drift toward sleep, some of that air was made by something so small you could not see it with the naked eye, floating on the surface of an ocean you may never visit, doing what it has done for billions of years.
The ocean is home to the largest animal that has ever lived on Earth. Not the dinosaurs. Not the ancient sea monsters of the Mesozoic.
The largest animal in Earth's history is alive right now, swimming in the same oceans that cover our planet today.
The blue whale.
A blue whale can reach 30 meters in length and weigh as much as 200 tons.
Its heart is the size of a small car. Its heartbeat can be heard from 2 miles away.
A child could crawl through its largest arteries. And yet the blue whale eats nothing but tiny shrimp-like creatures called krill, filtering millions of them from the water with every enormous mouthful. The largest thing that has ever lived, sustained entirely by some of the smallest.
Sound travels 4 times faster in water than in air.
In air, sound moves at about 340 meters per second. In seawater, it travels at roughly 1,500 meters per second, and it can travel extraordinary distances.
Blue whales exploit this property.
Their low-frequency calls, too deep for human ears to hear without equipment, can travel thousands of miles through the ocean.
A whale in the Pacific can, in theory, be heard by another whale near Antarctica. The ocean is full of sound, if you know how to listen. The clicks of sperm whales.
The songs of humpbacks. The distant rumble of underwater earthquakes.
The crack of ice calving off glaciers. It is not silent down there. Not at all.
There is a place in the ocean called the SOFAR channel, the sound fixing and ranging channel, where sound can travel almost indefinitely. It sits at a depth of about 1,000 meters, where temperature and pressure combine to create a kind of acoustic highway. Sound waves bend toward this channel from above and below, trapped and guided along it, losing almost no energy. During World War II, the military discovered this channel and used it to help locate downed pilots. A pilot who survived a crash could set off a small explosive charge. The sound would enter the SOFAR channel and travel thousands of miles to listening stations, allowing rescuers to triangulate their position. The ocean, it turns out, had been carrying messages all along. The midnight zone begins at about 1,000 meters depth, where the last traces of sunlight finally disappear.
At this depth, the water is completely, absolutely black.
Not the darkness of a room with the lights off.
Not the darkness of a cloudy night. True darkness.
The kind of darkness that has never known light.
And yet the midnight zone is full of life. Animals that make their own light.
Animals that are themselves transparent, their organs, their stomachs, even their hearts visible through their skin like living glass sculptures. In a world where there is no light from above, life found another way. Bioluminescence, the ability to produce light, is the most common form of communication in the deep ocean.
More than 76% of deep-sea animals can produce their own light. They use it for everything. To attract prey. To signal potential mates. To confuse predators.
To recognize their own species in the darkness. The light is usually blue-green, the wavelength that travels furthest through water.
It pulses. It flashes. It glows in steady halos.
If you could somehow see the midnight zone in its entirety, it would look like a dark sky full of living stars, flickering, moving, signaling, alive.
The anglerfish is perhaps the most famous hunter of the deep ocean.
The female, for it is only the females who hunt, carries a bioluminescent lure on a long filament that extends from her forehead like a fishing rod.
She hangs in the darkness and waits.
Other animals, drawn to the light, swim toward what they think might be food or a mate. They do not realize their mistake until it is too late.
The anglerfish's mouth is enormous relative to her body. Her teeth curve inward, so that anything that enters cannot easily escape.
She can swallow prey larger than herself, her stomach stretching to accommodate it. And she waits in the darkness with her little light, patient as time itself, for the ocean to bring her dinner. The male anglerfish is a tiny, sad, and remarkable creature.
He is many times smaller than the female.
And he has one purpose in life: to find a female and never let go. When a male finds a female, he bites into her body. His mouth fuses with her skin. His circulatory system merges with hers. Over time, his eyes degenerate. His internal organs dissolve. He becomes, essentially, a permanent parasite, little more than a sperm-producing appendage attached to her body. A single female anglerfish can carry several males attached to her at once, each one a shadow of what he was, reduced to a single biological function. It is, in the strange economy of the deep ocean, a kind of love.
The vampire squid is not actually a squid.
Despite its name, it belongs to its own order entirely, Vampiroteuthis infernalis, which translates, magnificently, as vampire squid from hell. It lives in the oxygen minimum zone, between 600 and 900 meters depth, a layer of water so depleted of oxygen that most animals cannot survive there.
The vampire squid thrives in it. Its blood contains a special protein that allows it to extract oxygen from water far more efficiently than other cephalopods. It is a living relic. Its lineage is ancient, more closely related to the ancestors of both squid and octopus than to either one specifically. When threatened, it does not release ink.
Instead, it inverts its cloak over its body and curls into a ball, covering itself with the spiny projections on its arms. It looks, in this posture, like nothing so much as a small dark pineapple. The deep ocean is full of such improbable solutions. Hydrothermal vents were discovered in 1977, and they changed everything we thought we knew about life.
Scientists had assumed that all life on Earth ultimately depended on sunlight. Plants convert sunlight to energy. Animals eat plants. Everything traces back to the sun.
Then, in 1977, a submersible exploring the Galapagos Rift found something no one expected. Cracks in the seafloor, venting superheated water rich in minerals. And around these vents, despite the complete absence of sunlight, life in extraordinary abundance.
Tube worms 2 meters long. White crabs. Clams. Fish. An entire ecosystem, thriving in total darkness, sustained not by sunlight but by the heat of the earth itself. The process is called chemosynthesis.
Certain bacteria convert the chemicals in the vent water directly into energy, no sunlight required. When scientists realized this, they also realized something profound: life does not need the sun.
Anywhere in the universe where there is liquid water and a chemical energy source, there could be life. The discovery of hydrothermal vents opened up the entire cosmos.
The tube worms that live around hydrothermal vents have no mouth and no digestive system.
They do not eat. They cannot eat.
They have no mechanism for eating. Instead, they are filled with a special organ called a trophosome, packed with billions of chemosynthetic bacteria. These bacteria process the hydrogen sulfide from the vent water, a gas toxic to most life, and produce energy. The tube worm provides shelter and raw materials. The bacteria provide food. The worm and the bacteria cannot live without each other. They have been doing this, in the darkness, at the bottom of the sea, for millions of years.
Hydrothermal vent water can reach temperatures above 400 degrees Celsius.
At sea level, water boils at 100 degrees.
But at the pressure of the deep ocean, water cannot become steam. The pressure keeps it liquid even at temperatures far beyond its normal boiling point.
So the water that pours from hydrothermal vents is superheated, scalding hot but liquid, before it mixes with the surrounding water, which is close to freezing. The vents exist in a world of extremes: crushing pressure, absolute darkness, scalding water, toxic chemicals.
And yet life finds a way. Life always finds a way.
Cold seeps are hydrothermal vents' quieter cousins. Instead of superheated water, cold seeps leak methane and hydrogen sulfide from the seafloor at temperatures close to the surrounding water. They are slower, gentler, and longer lasting than hydrothermal vents.
And like hydrothermal vents, they support entire ecosystems. The animals around cold seeps can live extraordinarily long lives.
Cold seep mussels can live for over 200 years. Tube worms at cold seeps may live for 250 years or more, making them among the longest-lived animals on Earth.
They grow slowly, in the cold darkness, century after century, undisturbed.
The ocean floor is covered in a layer called marine snow.
It is not snow.
It is a constant, slow fall of organic particles drifting down from the waters above, dead plankton, fragments of animals, fecal pellets, bits of organic material too small to see with the naked eye. It falls through the water column like a gentle, perpetual snowfall in slow motion. For many deep-sea creatures, marine snow is the primary food source, the only connection between the sunlit world above and the darkness below.
They wait for it.
They filter it from the water. They hunt the tiny organisms that feed on it. The deep ocean is fed by the rain of the dead. When a large animal dies in the ocean, a whale, for instance, its body sinks to the seafloor and creates what scientists call a whale fall. A single whale fall can sustain an entire community of deep-sea organisms for decades.
The process happens in stages.
First, mobile scavengers arrive, sleeper sharks, hagfish, crabs, and strip the soft tissue from the bones over months. Then enrichment opportunists colonize the bones and sediment, feeding on organic material. Finally, sulfophilic bacteria break down the lipids in the bones themselves, creating a sulfide-rich environment similar to a hydrothermal vent. A single dead whale becomes, in stages, an entire ecosystem.
A temporary island of abundance in the vast cold darkness. The giant squid was considered a myth for most of human history.
Sailors called it the Kraken. It appeared in ancient maps, in legends, in the nightmares of men who spent their lives at sea. But for centuries, science had no proof it existed. Then bodies began washing up on shores.
Tentacles the diameter of a human thigh.
Eyes the size of dinner plates, the largest eyes of any animal on Earth, evolved to gather the faintest traces of light in the deep ocean. The giant squid can reach 13 meters in length. It was not photographed alive in its natural habitat until 2004. Not filmed until 2012. For most of human history, the most magnificent predator in the ocean was a rumor.
The colossal squid is even larger than the giant squid. It lives in the deep waters around Antarctica.
It has hooks on its tentacles, rotating hooks, like grappling tools, which it uses to grip prey. Its eyes are the largest of any animal ever recorded, up to 27 centimeters in diameter, roughly the size of a dinner plate. These extraordinary eyes likely evolved to detect the bioluminescent flashes of sperm whales hunting in the deep, giving the squid a chance to escape before the whale arrives.
We know very little about how the colossal squid lives.
We have never seen one behaving normally in the wild. Almost everything we know comes from specimens found in the stomachs of sperm whales, or dead animals recovered from Antarctic waters. It hunts and is hunted in a world we have barely glimpsed. Sperm whales dive to depths of over 3,000 meters in pursuit of their prey. They can hold their breath for up to 90 minutes. Their muscles are packed with myoglobin, a protein that stores oxygen, at concentrations so high that their flesh is nearly black. When a sperm whale dives, its heart rate slows dramatically. Blood is redirected away from non-essential organs and concentrated in the heart and brain. The ribcage collapses slightly under pressure, compressing the lungs. The whale descends in darkness, clicking loudly, using echolocation to find squid in the black water, the sound bouncing back from every obstacle, painting a picture of the deep through sound alone. Then it climbs back toward the light, breathing again, carrying the darkness inside it. The sperm whale's click is the loudest sound produced by any animal on Earth. It can reach 230 decibels. For comparison, a jet engine at close range produces about 140 decibels. A gunshot, about 160.
230 decibels is loud enough to stun or kill a human being. Some scientists believe sperm whales may actually use their clicks offensively, firing a focused beam of sound at prey to stun or disorient them before striking.
This has never been conclusively proven, but the physics would allow for it. In the darkness of the deep ocean, sound is both sense and weapon.
The barrel-eye fish has a transparent head.
Its skull is a dome of clear, gelatinous material, and through it you can see directly into the fish's head where its tubular eyes sit, pointing upward. These unusual eyes are extraordinarily sensitive to light. They rotate within the transparent dome, tracking objects above and to the sides. In very low light, the fish can detect the faint silhouettes of prey moving above it against the dim glow of the twilight zone. When scientists first observed barrel-eye fish in their natural environment using underwater cameras, they were startled. The fish looked completely different from the specimens that had been brought to the surface. The transparent dome, which collapses under the change in pressure during collection, had never been preserved in museum specimens. For decades, we had been looking at this animal incorrectly. The ocean has its own weather systems. Deep below the surface, massive currents move water around the globe in a slow, continuous cycle that oceanographers call the thermohaline circulation, or, more poetically, the ocean conveyor belt. It works on the difference in density between warm and cold water, and between fresh and salty water.
Cold, salty water is denser and sinks.
Warm, less salty water is lighter and rises. This circulation moves water from the surface of the North Atlantic all the way to the deep ocean floor, across the seafloor, back up near Antarctica, and around again.
A single molecule of water might take 1,000 years to complete the journey.
This conveyor belt regulates the climate of the entire planet. Without it, Britain and Northern Europe would be as cold as Canada at the same latitude. The deep ocean breathes, slowly, and the breath of it shapes the world.
There are rivers in the ocean.
When water from the surface becomes very cold and very salty near the poles, where ice forms and leaves its salt behind in the water, it becomes dense enough to sink rapidly.
This dense water flows along the seafloor in channels, following the contours of underwater mountain ranges and valleys.
These flows behave very much like rivers.
They have banks.
They carve channels. They can travel thousands of miles from where they formed. On the seafloor of the Black Sea, there is a river, a genuine, flowing river of dense, salty water that runs along the bottom of the sea, its banks defined by the chemistry of the water rather than rock.
Fish swim along its banks. Sediment settles in its bed. A river. Underwater. In the dark.
The deepest fish ever recorded was found in the Mariana Trench at a depth of 8,336 meters. It was a snailfish, a small, pale, translucent creature that looks entirely unremarkable. Its body is soft and flexible, which allows it to withstand the crushing pressure of the deep.
At that depth, the pressure is over 800 atmospheres.
Imagine standing at the bottom of a stack of 800 cars.
That is the weight pressing on every square inch of the snailfish's body.
And the fish swims
calmly, going about whatever business snailfish have at the bottom of the world. The hagfish is one of the oldest vertebrate lineages on Earth.
It has remained essentially unchanged for over 300 million years.
It was here before the dinosaurs. It was here after them. The hagfish has no jaw, no stomach. It feeds by burrowing into dead or dying animals and absorbing nutrients directly through its skin. And when threatened, the hagfish releases a remarkable defense, slime. Not ordinary slime.
Within a fraction of a second, the hagfish can produce enough slime to fill a bucket, a slime that expands rapidly in seawater, clogging the gills of any predator foolish enough to attack it. The slime is made of threads thinner than silk, so strong that scientists have investigated it as a potential material for bulletproof vests. 300 million years of evolution, and the solution it arrived at was an incomprehensible amount of slime.
The mimic octopus can impersonate over 15 different species.
Most animals that use mimicry impersonate one thing: a leaf, a rock, a specific dangerous species.
The mimic octopus does something far more sophisticated. It can flatten itself and ripple along the seafloor to look like a flounder. It can tuck 6 of its arms behind it and wave the other 2 to imitate a banded sea snake. It can spread its arms wide and sink to the bottom to mimic a lionfish. But more remarkably, it appears to choose which species to impersonate based on context, specifically, based on what kind of predator is approaching. If a damselfish is the threat, a fish whose main predators are sea snakes, the octopus becomes a sea snake. It reads the situation, selects the appropriate disguise, and performs it. An intelligence solving a problem in the dark at the bottom of the sea. Octopuses have 3 hearts and blue blood. 2 hearts pump blood through the gills. 1 pumps it through the rest of the body. When an octopus swims rather than crawls, the heart that supplies the body stops beating entirely, which is why octopuses tire so quickly when swimming and prefer to walk along the seafloor. Their blood is blue because it uses copper-based hemocyanin to carry oxygen, rather than the iron-based hemoglobin that makes our blood red. Hemocyanin is less efficient than hemoglobin in warm conditions, but far more efficient in cold, low-oxygen environments, exactly the conditions of the deep ocean. Cold and blue and 3-hearted. Moving through the dark on 8 arms. Each arm of an octopus has its own neural cluster, its own miniature brain. 2/3 of an octopus's neurons are in its arms, not in its central brain. This means an octopus arm can taste, touch, and make decisions semi-independently of the central brain. An arm can explore a crevice, test a shell, and begin to manipulate it, all while the octopus's main brain is attending to something else entirely. In a sense, an octopus is not one mind but 9, operating in loose coordination. The Humboldt squid hunts in packs. Off the coast of the Pacific Americas, in deep water during the day and shallower water at night, Humboldt squid, which can reach 2 meters in length and weigh over 50 kilograms, hunt cooperatively. They flash bioluminescent patterns at each other as they hunt, patterns that may coordinate the group's behavior, divide up prey, signal the direction of a school of fish. They are fast, aggressive, and powerful. Divers who have encountered them in the water describe the experience as deeply unsettling: 1,000 eyes in the dark, flashing lights, bodies moving with impossible speed. The ocean is full of intelligence we have not yet learned to read. There are lakes at the bottom of the ocean. Not metaphorical lakes. Actual lakes of bodies of water sitting on the seafloor, with distinct surfaces, shorelines, and even waves. They form when the seafloor leaks brine, water so saturated with salt that it is far denser than the surrounding seawater. This brine pools in depressions on the seafloor, and because it does not mix easily with the less dense water above it, it sits there, still and separate, a lake within an ocean. The brine in these lakes is typically so salty and so rich in methane that most animals cannot survive in it. The shorelines, however, are often ringed with life organisms that can tolerate the extreme chemistry of the transition zone. If you could somehow see one of these lakes, it would look uncanny. Still water, with a distinct surface. Waves that behave like waves. A shoreline. At the bottom of the sea. The pressure in the deep ocean does not crush life, it shapes it. Animals that live in the deep ocean have evolved in ways that make the pressure not just tolerable but irrelevant. Their cells, their proteins, their biochemistry are all adapted to function at pressures that would kill surface animals immediately. Some deep-sea fish have no swim bladder, the gas-filled organ that surface fish use to control their buoyancy. A swim bladder full of gas would be crushed to nothing at depth. Instead, deep-sea fish maintain neutral buoyancy through fat-filled tissues, which compress gracefully under pressure. Deep-sea invertebrates have body fluids whose chemistry is specially adapted not to be affected by pressure changes. Their enzymes work correctly at 800 atmospheres.
Bring them to the surface and it is the decompression, the lack of pressure, that kills them.
Up is lethal. Down is home.
The ocean floor is covered with manganese nodules, potato-sized rocks that contain valuable metals. They form over millions of years, accreting mineral by mineral around a tiny nucleus, a shark's tooth, a fragment of bone, as metals precipitate from the seawater. They are found across vast stretches of the abyssal plain, lying loose on the sediment, available to be picked up. They contain manganese, but also cobalt, nickel, and copper, metals that are increasingly valuable in a world that runs on batteries and electronics. This has made the abyssal plain attractive to mining companies. The debate about whether to mine them, whether the economic value outweighs the destruction of ecosystems that may take millions of years to recover, is one of the defining environmental arguments of our time. The deep ocean, which has never been touched, may not remain untouched much longer.
The largest mountain range on Earth is underwater.
The mid-ocean ridge system stretches for over 65,000 kilometers, nearly 1.5 times the circumference of the Earth. It runs through every ocean on the planet, a continuous chain of underwater mountains where tectonic plates are pulling apart and new seafloor is being created.
Magma wells up from below, cools, and becomes rock.
The seafloor spreads outward from the ridge at a rate of a few centimeters per year. Most of this mountain range has never been seen by human eyes.
Its peaks are taller than the Alps. Its valleys deeper than the Grand Canyon.
It is the most significant geological feature on Earth, and almost no one knows it exists. The ocean floor is young, geologically speaking. Because the seafloor is constantly being created at the mid-ocean ridges and destroyed at subduction zones, where one plate slides under another, no ocean floor is older than about 200 million years.
The continents are ancient. Some continental rocks are over 4 billion years old, almost as old as the Earth itself. But the ocean floor is new. Constantly refreshed. Constantly being swallowed back into the mantle and reborn. The ocean erases its own history. There are underwater volcanoes called seamounts that never break the surface.
There are over 100,000 seamounts in the world's oceans, most of them unmapped. They rise thousands of meters from the seafloor but never reach the waves.
Seamounts are biodiversity hotspots.
Their slopes are covered in cold water corals that grow over centuries into forests of extraordinary complexity.
Their peaks create upwellings that bring nutrient-rich water to the surface. Fish gather around seamounts in enormous numbers. Tuna, sharks, and deep-sea species congregate in the currents around their peaks. Where there is a seamount, there is life. And most of them have never been visited. Cold water corals can live for thousands of years. Unlike their tropical cousins, cold water corals do not need sunlight, they capture food particles from the water. They grow slowly, a few millimeters per year, building complex three-dimensional structures that become habitats for hundreds of other species. Some cold water coral reefs are so old they were growing when the Roman Empire was at its height. They exist in total darkness, in water near freezing, in some of the most remote places on Earth. And they are extraordinarily fragile. A single pass from a deep-sea trawling net can destroy in minutes a structure that took 1,000 years to grow. The ocean contains vast plains called abyssal plains that are the flattest places on Earth. At depths between 3,000 and 6,000 meters, far from the activity of mid-ocean ridges and trenches, the seafloor is covered in a thick layer of soft sediment, the accumulated marine snow of millions of years. This sediment smooths everything. Mountains become gentle rises. Valleys become shallow depressions. The abyssal plains are immense. They cover more than half of the Earth's surface and are almost entirely unexplored. They are also extraordinarily still. Currents at those depths are slow. Disturbances are rare. Sediment that settles onto the abyssal plain may remain undisturbed for millions of years.
It is the quietest place on Earth.
The ocean stores 50 times more carbon than the atmosphere.
The ocean absorbs carbon dioxide from the air, and marine organisms, particularly tiny shell-forming creatures, incorporate carbon into their bodies. When they die, they sink, carrying their carbon with them to the deep ocean floor.
Over millions of years, these shells have accumulated into thick layers of sediment.
The limestone that covers much of the land, the chalk cliffs, the limestone plateaus, was once ocean sediment.
The ocean is the planet's carbon archive.
Every stone wall built from limestone, every chalk mark on a blackboard, contains within it the compressed remains of ancient marine life.
The deep ocean remembers everything.
There is a place in the North Pacific called the Great Pacific Garbage Patch, a region where ocean currents concentrate floating plastic debris into a diffuse, spread out accumulation roughly 3 times the size of France.
It is not a solid island of plastic.
It is more like a soup, particles of plastic at various sizes, from large fragments down to microplastics too small to see.
These particles have entered the food web. Zooplankton eat microplastics. Small fish eat the zooplankton. Larger fish eat those fish. The plastic moves up the food chain, concentrating as it goes. We have found microplastics at the bottom of the Mariana Trench, in the deepest sediment on Earth. Plastic has reached places where no human has ever been. The ocean is acidifying.
As the ocean absorbs more carbon dioxide from the atmosphere, it becomes slightly more acidic, a change that seems small in absolute terms but has enormous biological consequences. Shell-forming organisms, corals, oysters, pteropods, the tiny creatures at the base of many ocean food webs, need calcium carbonate to build their shells. In more acidic water, calcium carbonate dissolves. The shells grow thinner,
more fragile. Some organisms fail to form shells at all. The acidification happening now is faster than at any point in the last 300 million years.
The ocean is changing faster than the creatures in it can adapt.
The deep ocean is patient. But it is not infinitely patient.
The ocean floor near Antarctica contains the clearest water on Earth. With almost no phytoplankton, the microscopic organisms that give most ocean water its greenish tinge, and very little suspended sediment, the water in some Antarctic regions is transparent to depths of 80 meters or more.
Diving in these waters, you could look down and see the seafloor far below you with extraordinary clarity.
You would feel suspended in space, the void beneath you stretching down in absolute transparency.
It is the most alien underwater environment on Earth. And one of the most beautiful.
Narwhals, the unicorns of the sea, use their tusks to hunt. The narwhal's tusk is actually an elongated tooth that can reach 3 meters in length.
For centuries, scientists debated its purpose. Was it for fighting? For attracting mates? For breaking ice?
In 2017, underwater drone footage finally provided an answer. Narwhals were filmed using their tusks to stun Arctic cod, tapping the fish with the tip of their tusk to disorient them before eating them.
The tusk is also densely packed with nerve endings. It is a sensory organ, able to detect changes in water temperature, pressure, and salinity.
A tooth that is also a weapon, also a sensor, pointed at the Arctic darkness.
Mantis shrimp have the most complex eyes of any known animal.
Human eyes have 3 types of color receptor.
Some birds have 4. The mantis shrimp has 16.
They can see ultraviolet light, infrared light, and polarized light. Their eyes can move independently of each other and can scan in 3 dimensions simultaneously. What the world looks like to a mantis shrimp is impossible for a human being to imagine. The colors and patterns that are invisible to us may be blazing with information, signals, warnings, identifications that make the ocean a completely different place depending on what kind of eyes you bring to it. The mantis shrimp punches with the force of a bullet. Its dactyl clubs, the specialized limbs it uses to strike, accelerate to about 80 km per hour in less than 3 milliseconds. The impact is so fast that it causes cavitation, the formation and immediate collapse of small bubbles in the water, which generates a shockwave that can stun or kill prey even without a direct hit. The clubs move fast enough to crack aquarium glass.
Scientists who study mantis shrimp must use special tanks, because a mantis shrimp can break through ordinary glass simply by striking it.
The fastest punch in the animal kingdom, thrown by a creature 8 inches long, at the bottom of the sea. Some jellyfish are technically immortal. The Turritopsis dohrnii, a jellyfish species found in the Mediterranean and other warm seas, has the ability to revert to its juvenile form when stressed, old, or ill. When conditions become unfavorable, the adult jellyfish sinks to the seafloor and transforms, its body reverting to a blob of undifferentiated cells, which then reorganize into a polyp, the juvenile form of the jellyfish.
The whole life cycle begins again. In theory, this process can repeat indefinitely.
The jellyfish does not die of old age.
It simply begins again.
A creature that cheats death by becoming a child once more, over and over, in the shallow sea. The ocean holds enough gold dissolved in its waters to give every person on Earth 9 pounds of it. Not concentrated gold in solution, dispersed throughout the enormous volume of the ocean at concentrations of about 13 parts per trillion.
The total amount is estimated at around 20 million tons. We have no economical way to extract it. The energy cost of processing enough seawater to recover meaningful amounts would far outweigh the value of the gold recovered. But it is there. Dissolved in the water. In every ocean, in every sea.
The most valuable thing in the world, everywhere, unrecoverable. The deep ocean is home to creatures that can survive being frozen, boiled, and exposed to radiation that would kill any other known organism. They are called tardigrades, or, affectionately, water bears. They are not exclusive to the ocean, but they thrive there. 8-legged, microscopic, and essentially indestructible, tardigrades have survived all 5 of Earth's mass extinction events. They have been sent into space and survived exposure to the vacuum and radiation of low Earth orbit. When conditions become unfavorable, they enter a state called cryptobiosis, drying out almost completely, their metabolism dropping to 0.01% of normal. They can remain in this state for decades and then revive when conditions improve. Life, reduced to its absolute minimum, waiting for better times.
The Mariana Trench is not the loneliest place in the ocean. In the middle of the South Pacific, there is a region called Point Nemo, officially the oceanic pole of inaccessibility. It is the point in the ocean furthest from any land. The nearest land is 2,688 kilometers away. The nearest humans are often the astronauts aboard the International Space Station, which passes overhead at about 400 kilometers altitude. At Point Nemo, there is nothing.
No land in any direction for as far as the eye could see and far beyond. Just water, under a sky unbroken by any coast.
It is also used as a spacecraft cemetery. Satellites and space stations are deliberately deorbited to fall into the ocean near Point Nemo because it is the place on Earth least likely to cause harm when something falls from space. The loneliest place on Earth is a graveyard for spacecraft. The ocean has its own postal service. Scientists sometimes release bottles, or, now, scientific buoys, to track ocean currents. These drifters send their location back by satellite, allowing researchers to follow the paths of currents across the ocean. But long before satellites, people sent messages in bottles. And some of those bottles traveled extraordinary distances. A bottle released off the coast of Scotland in 1914 was found in 2012, 98 years later, on a beach in Germany. It had been drifting for nearly a century. A message in a bottle is the slowest form of communication on Earth, and the most patient. The ocean delivered it anyway.
Sharks have been on Earth for over 450 million years.
They are older than trees. Trees evolved around 385 million years ago. Sharks were already ancient by then.
They have survived all 5 mass extinctions. The asteroid that killed the dinosaurs barely touched them. The shark body plan, streamlined, efficient, equipped with teeth that replace themselves throughout a lifetime and electroreceptors that can detect the electrical fields generated by other animals' heartbeats, worked so well the first time that evolution saw little reason to change it.
The animal you fear is not a monster.
It is a perfect solution to a problem that has existed for nearly 500 million years.
The Greenland shark is the longest-lived vertebrate animal on Earth.
Greenland sharks grow about 1 centimeter per year and can live for over 400 years. The oldest individual ever recorded was estimated to be between 272 and 512 years old, based on radiocarbon dating of proteins in its islands, proteins that form early in the animal's development and do not turn over throughout its life. A Greenland shark alive today may have been born before Shakespeare was writing his plays. It moves through the Arctic and North Atlantic in near freezing water, slowly, patiently, eating whatever it finds.
It does almost everything slowly. Its heart beats about once every 10 seconds.
For centuries of cold, slow, patient living, the ocean produces sounds that no one has been able to fully explain. In 1997, NOAA, the American Oceanic Monitoring Agency, recorded an ultra-low-frequency sound in the Pacific Ocean they named the bloop. It was extraordinarily loud, detected by sensors thousands of miles apart.
Initial theories ranged from a giant undiscovered animal to geological activity.
Further analysis eventually concluded that the bloop was likely the sound of a large iceberg cracking and calving on the Antarctic seafloor. But for a few years, the bloop was unexplained. And in the ocean, unexplained sounds feel different than they do on land.
The ocean is large enough to hide anything. The Mariana Trench contains unexpected amounts of life.
When scientists first explored the deepest parts of the ocean, they expected to find nothing or almost nothing.
The pressure was too extreme. The darkness was absolute.
The cold was intense. What they found instead was a diverse community of organisms.
Bacterial mats covering the seafloor. Tiny amphipods, shrimp-like creatures, in enormous numbers.
Foraminifera, single-celled organisms with shells, visible to the naked eye, covering the sediment.
Life does not thin out in the deep ocean the way scientists expected. It changes. It adapts. It finds new forms.
The deepest place on Earth is not empty.
It is alive.
Some deep-sea fish produce light through a different mechanism than other bioluminescent animals. Most bioluminescent animals produce their own light through a chemical reaction in specialized cells called photophores. But some deep-sea fish, including certain species of lanternfish and dragonfish, harbor colonies of bioluminescent bacteria in special light organs.
They do not produce light. They farm it. The bacteria glow.
The fish provide the bacteria with nutrients. The light is a product of a partnership, a colony of microscopic organisms living inside a larger one, both benefiting from the arrangement.
Even in the deep ocean, life cooperates. The ocean has tides that go all the way down.
The gravitational pull of the moon and sun doesn't just move the surface of the ocean.
It creates internal waves, waves that form at the boundaries between layers of water with different densities, deep below the surface.
These internal tides can be enormous, hundreds of meters in height, but completely invisible from the surface, moving silently through the deep water.
They mix the ocean.
They stir nutrients up from depth. They play a crucial role in the circulation patterns that regulate the planet's climate.
The moon moves the deep ocean as surely as it moves the shore. You simply cannot see it happening. The ocean has a memory.
Water takes a very long time to complete a full circuit of the global ocean conveyor belt, about 1,000 years on average, though some pathways take much longer. This means that water currently being added to the deep ocean, water that sinks now from the surface of the North Atlantic, will not re-emerge at the surface for 1,000 years. And it means that the deep water currently upwelling in the Pacific was last at the surface before European explorers reached the Americas. The ocean carries the past inside it. Ancient water, cold and dark, making its way slowly back toward the light, carrying with it the chemical signature of a world that no longer exists. A single liter of seawater contains millions of viruses. The ocean is the most virus-rich environment on Earth. These viruses infect bacteria and other microorganisms, and their activity is critical to the health of ocean ecosystems. Viral infections of phytoplankton can collapse entire blooms, populations of trillions of organisms dying within days as viruses spread through the population. This releases enormous quantities of organic material into the water, feeding other organisms. The virus controls the bloom. The bloom feeds the ocean. The ocean feeds the world. Everything is connected, even the smallest things. The ocean doesn't end at the seafloor. Below the sediment, below the solid rock, life continues. Scientists have found microorganisms living in rock kilometers below the seafloor, surviving with almost no energy, metabolizing incredibly slowly, dividing perhaps once every few thousand years. The biosphere extends into the crust of the Earth itself. We do not yet know how deep it goes. We do not know the full extent of this subterranean ocean of life. But it is there, in the rock, in the darkness, beneath the darkness, alive. The ocean is louder now than it was 50 years ago. Ship traffic, sonar, offshore drilling, and seismic surveys have increased the ambient noise level in the ocean dramatically since the mid-20th century. This matters because ocean animals rely on sound for navigation, communication, and hunting. Whales sing to each other across ocean basins. Dolphins navigate by echolocation. Fish communicate by sound. In a noisier ocean, these signals become harder to detect. Whales have been documented shifting their calls to higher frequencies, presumably to be heard above the background noise. They have adapted. But adaptation has limits. The ocean we are creating is different from the ocean that existed. And the animals in it are responding. The ocean floor is littered with the wreckage of history. Every war fought near the sea left its mark on the seafloor. The hulks of ancient trading ships. Roman amphorae still sealed, still containing traces of olive oil or wine. The wrecks of wooden vessels from the age of sail, preserved by the cold and the absence of wood-boring organisms in deep water. And the wrecks of the 20th century warships, submarines, aircraft lying in the darkness where they fell. Some of these wrecks are themselves ecosystems now, colonized by corals and sponges and fish. A sunken ship becomes a reef, becomes a habitat. The history of human conflict has become the architecture of marine life. Some deep-sea creatures eat rock. Certain worms, mollusks, and bacteria extract energy directly from iron and sulfur compounds in the rock itself, a process called lithotropy, from the Greek for rock eating. They do not need organic material. They do not need the sun. They need only the chemical energy locked in the minerals of the seafloor. These organisms are among the most extreme life forms on Earth and among the most interesting to astrobiologists, who wonder if similar organisms might exist inside rocky planets elsewhere in the solar system. Life-eating rock in the dark, miles underwater, providing a model for what might be alive somewhere else entirely. The ocean has been mapped by ear more thoroughly than by sight. Cold War-era military listening networks, designed to detect Soviet submarines, covered the entire Pacific and Atlantic Oceans with arrays of sensitive hydrophones. These networks recorded everything, not just submarines but whale calls, underwater earthquakes, distant storms, and sounds that have never been explained. Much of this data has been declassified and is now used by oceanographers and biologists. The Cold War's ear on the ocean turned out to be one of the most valuable scientific instruments ever created, inadvertently.
We listened for enemies and found a world. Ocean trenches are formed where one tectonic plate slides under another.
At subduction zones, the older, denser oceanic plate dives beneath the lighter continental or younger oceanic plate, plunging back into the mantle.
As it descends, it takes water and sediment with it.
This subducted water lowers the melting point of the mantle rock above it, triggering volcanic activity. The ring of volcanoes that encircles the Pacific, the Ring of Fire, is a direct product of this process. The deepest places on Earth and the most volcanically active places on Earth are intimately related. The trenches and the volcanoes are part of the same system, the slow, grinding recycling of the seafloor, the ocean consuming itself and being reborn. Jellyfish have no brain, no heart, and no blood. They have existed for over 500 million years, predating even the sharks.
They are among the simplest complex animals on Earth. Their body is 95% water.
They have no active propulsion, they can only pulse to rise in the water column, then drift where the current takes them. Their tentacles are studded with specialized stinging cells that fire automatically when triggered by contact.
They do not think. They do not navigate. They drift. And yet they are one of the most successful animals in ocean history.
When conditions are right, jellyfish bloom in numbers that stagger the imagination, billions of animals clogging the water, overwhelming ecosystems that evolved without them in such quantities.
Success does not require a brain.
It requires patience, and time, and the right conditions.
The ocean floor near mid-ocean ridges is entirely different from the abyssal plain. The ridges are geologically young and volcanically active.
The rock is fresh, black basalt.
Hydrothermal vents cluster along the ridge crests.
The seafloor moves, shifts, occasionally splits open to release new magma. Moving away from the ridges, the seafloor ages.
The basalt cools and sinks slightly under its own weight. Sediment accumulates.
By the time you reach the abyssal plain, the rock is covered in a thick blanket of marine snow accumulated over millions of years. A single dive across the seafloor, moving from a mid-ocean ridge toward the deep plain, would be like walking through a billion years of geological time. The word abyssal comes from the Greek for bottomless.
The ancient Greeks were not entirely wrong.
Standing on the deck of a ship over the abyssal plain and lowering a rope, as early oceanographers did, you could run out of rope, thousands of meters of it, without touching the bottom. For the people who first tried to measure the ocean, it must have seemed genuinely bottomless. The word we use for the deepest part of the ordinary ocean is a word for something that cannot be reached, cannot be measured, cannot be comprehended.
And in a way, even now, that is still true. The ocean contains more history than any library. Sediment cores drilled from the seafloor contain a continuous record of Earth's climate and oceanography stretching back hundreds of millions of years. Each layer of sediment is a snapshot of the conditions that existed when it was deposited, the temperature of the water, the chemistry of the atmosphere, the species that were alive. Reading these cores is like reading a book in which each page is 1,000 years of Earth history. The record of every mass extinction, every ice age, every warm period, every meteor impact that affected the ocean is stored in the sediment at the bottom of the sea. The deep ocean remembers. It holds everything. Patient and cold and permanent, it holds the entire story of our world. Sound can illuminate the deep ocean the way light illuminates the surface. Sonar, sound navigation and ranging, sends pulses of sound into the water and listens for the echoes. By analyzing the returning sound, scientists can build detailed maps of the seafloor without ever seeing it.
Modern multi-beam sonar can map swaths of seafloor kilometers wide in a single pass, creating images of extraordinary detail revealing mountain ranges, valleys, volcanic fields, and the tracks of ancient currents written in the sediment. The deep ocean, which has never been seen, has been listened to.
And listening is its own kind of seeing.
The deepest submersible dive in history was made by James Cameron in 2012. Cameron, the film director, descended to the bottom of Challenger Deep, an especially designed submersible called Deep Sea Challenger, a vehicle shaped like a vertical torpedo, designed to descend as quickly as possible to minimize the time spent at depth. He spent about 3 hours at the bottom of the world, collecting samples and filming.
What he found was a flat, barren-looking plain of sediment. Almost no fish. A few amphipods. The lights of the submersible illuminating a circle of seafloor that no human eye had ever seen. And beyond the circle of light, complete darkness. The rest of the deepest place on Earth, stretching in every direction, unseen, still unknown.
The ocean has been explored less than the surface of the moon. We have detailed maps of the entire lunar surface, created by orbital satellites. We have driven rovers across Mars. We have sent probes to Pluto and beyond. But the ocean floor, 2.5 times the area of all the world's land combined, remains mostly unmapped and almost entirely unvisited.
The reason is partly practical. Water is opaque to the electromagnetic radiation used for remote mapping, so you have to physically go there.
And the deep ocean is profoundly hostile to human technology, crushing pressure, corrosive saltwater, absolute darkness.
Space is easier. Space is empty.
The ocean is full, and full of things that push back. New species are discovered in the ocean every year.
The deep ocean is the last great frontier of biodiversity on Earth. Scientists estimate that only a small fraction of deep-sea species have been described. Every expedition to previously unexplored areas returns with specimens that have never been seen before.
Creatures that look like nothing in the existing literature. Animals for which new categories must be created. Life that evolved in complete isolation from the surface world, over millions of years, into forms that would have seemed like fantasy if described before they were found.
The ocean is still surprising us.
It has been doing so since the first person leaned over the side of a boat and wondered what was below the surface. And it will keep surprising us for a long time to come. The ocean breathes on a geological timescale.
Over millions of years, the distribution of land and sea changes as tectonic plates move. Shallow inland seas cover areas that are now land.
Continents drift apart, closing ocean basins or opening new ones. The ocean we know today, the Pacific, the Atlantic, the Indian, is not the ocean that existed 200 million years ago, and it is not the ocean that will exist 200 million years from now.
The Tethys Sea that once lay between the ancient continents is now mostly gone, its sediments folded into the mountains of Europe and Asia. The Mediterranean is a remnant of it.
The Atlantic is young, it began opening about 180 million years ago, and it is still widening today at the rate of about 2.5 centimeters per year.
The ocean is not permanent. It is the surface expression of forces far deeper and far older than the water itself.
The deep ocean is full of animals that have never been named. For every species described by science, there are likely many more waiting in the unexplored regions of the deep. We have sampled only a tiny fraction of the seafloor. We have visited only a small number of deep-sea habitats. Somewhere in the unmapped deep, there are creatures living their lives, hunting, mating, dying, that no human being has ever seen.
They exist. They are real.
They are not waiting to be discovered, they simply are. The ocean holds an entire undescribed world within it. A world of animals with names we have not given them yet, living in places we have not visited, doing things we do not understand. It is one of the most remarkable facts about the Earth we live on. The largest part of it remains unknown.
The ocean at night looks different than the ocean by day.
At the surface, as the light fades, many deep-sea animals rise toward the surface in what is called the Deal vertical migration, the largest coordinated movement of animals on Earth. During the day, these animals, fish, squid, krill, copepods, retreat to depths where the darkness protects them from predators that hunt by sight. At night, they rise to the surface to feed on the phytoplankton that live in the sunlit waters. Every night, across every ocean, billions of animals make this journey.
Every morning, they descend again.
A daily tide of life, rising and falling with the sun, connecting the surface and the deep in a pulse that has continued, uninterrupted, for hundreds of millions of years.
We are made of the ocean.
The salt concentration in human blood is remarkably similar to the salt concentration of the ancient sea in which the first complex animals evolved. Our bodies, when they need to maintain the right chemical balance, reach for the same solution that the ocean found billions of years ago.
We carry the sea inside us. In our tears. In our sweat. In the amniotic fluid in which we began.
Life crawled out of the ocean long ago, but it never fully left. It brought the ocean with it, sealed inside, a memory written in chemistry. When you float in the sea, when the salt water holds you up and the waves move gently around you, you are returning to something older than memory. Something the body remembers even when the mind has forgotten.
The ocean is where life began.
And in some sense, the ocean is,
and so we rise.
Slowly, through the layers we descended through at the beginning. Past the hatal darkness and the crushing silence of the abyss. Past the snow falling upward through cold water.
Past the bioluminescent lights that flicker and go out as we pass.
Through the midnight zone, where nothing from above has ever reached. Through the twilight, where the last traces of color still exist in the water. And up, finally, into the surface world.
Where the light is. Where you are.
You have spent tonight in one of the least known places on Earth. You have met animals that make their own light, animals that eat rock, animals that have survived 5 extinctions and have no intention of noticing a 6th. You have visited rivers that flow at the bottom of the sea, lakes that sit within the ocean, mountains taller than any on land.
The deep ocean is there, right now, as you breathe. Below the surface of every sea on Earth. Patient. Cold.
Full of life so strange it barely seems real. It has been there for a very long time.
Long before us.
It will be there for a very long time after. And knowing it exists, that there is still a world so large and so unknown, so full of creatures and mysteries and things that have never been seen, is perhaps one of the most comforting thoughts available to a mind that sometimes feels the world has grown too small.
There is still so much we don't know. There is still so much wonder left. Let your breathing slow now.
Let the darkness behind your eyes become the darkness of deep water. Imagine the pressure gently holding you, the cold a distant thing, the silence absolute and complete and deeply, deeply peaceful.
You are safe at the surface.
But the deep is there below you, vast and alive and patient.
Sleep well. The ocean will keep its watch.